Thank you for that introduction. So, as mentioned, after spending most of my life and my career working in the automotive and industrial and high-tech industries, my inspiration for leaving a great career to join a company like Hortonworks was the opportunity to address business problems, especially in automotive, in ways that were, in many cases, not previously thought possible. So could I have a show of hands as to who of you are familiar with the term Hadoop? Let me just see. There's quite a few of you. Very good. Who of you are familiar with Hortonworks and what we do? Just a few of you. So maybe what I'll do is I'll just do a quick level set on the role of, on exactly what is Hadoop and what's Hortonworks' role in driving the innovation of Hadoop. And then I'll talk to how that's relevant for use cases within the connected car and the automotive ecosystem. And then I'm going to highlight some of the demos that we've got running in our booth, which I think are pretty game-changing. So if I can just take you back 10 years. 10 years ago, there was a team of engineers at Yahoo, and they were tasked with coming up with the next generation internet search engine. So what they needed to do was to capture every web page and all the links between the web pages and store that in multiple copies overnight for rapid search the next day. So they found that existing data management technologies couldn't handle the volume of data, they couldn't handle the variety of different data types, and they would also be cost prohibitive in terms of their proprietary software license models. So this team came up with a completely new paradigm of distributed storage and compute of data, where the storage of data is distributed amongst a pool of commodity servers, and we're talking white box servers, fairly low-cost servers, each with their own CPU, disk, and memory, and this combined resource has been leveraged to do amazing things, which I'm going to talk about. So this was called Hadoop, and with Hadoop, you're able to store data at scale, and it scales up to the exabyte range, if you know how big that is. It can handle any data type. It can allow you to bring all of your data into a single view. It can allow you to put that data into the hands of the business so that they can make sense of it and have the complete picture rather than pieces of the picture. And it is 2 to 3 orders of magnitude lower cost than any other data management technology because there is no license fee because it's open source, it's 100% open source, and also because it can run on commodity hardware. So it is quite a game changer. So Hortonworks was formed when those 24 engineers that created Hadoop 10 years ago, they were spun out to be the founders of our company. They realized that they were onto something big, but they didn't want to reinvent the wheel on data by themselves. So they decided that they wanted to work with a community of internet companies, companies like Microsoft and others, who have a common goal of establishing Hadoop as the cornerstone of the enterprise data architecture. So as I said, in terms of our business model, we don't sell a software license. Our business model is completely dependent on your success. So we provide a support subscription which helps you identify the kinds of big data use cases that are going to give you the best value, help you establish the right roadmap to achieve those, and if you're not happy, and also architect that into your environment. And if you're not happy with the results, it's typically a 1-year subscription, and every year is a voting year for Hortonworks. So if you look at the business problem that we're looking to address here, if you look at the data of a typical automotive manufacturer, between 80 and 90% of the data is either semi-structured or unstructured data types. And this could be sensor data from a connected car, it could be video, etc., lots of different data types. And the unstructured and semi-structured data types are growing exponentially, while the regular data that people typically deal with in relational systems like supply chain systems is growing modestly, but not that dramatically. But the real blind spot is the ability to correlate those structured data types with unstructured data to get the value out of it. And that's really where Hortonworks can help you to do that. So we are very well known for leading the innovation of the Hadoop data platform, which is the green hexagon that you can see on the right-hand side there. what we've also been able to do recently is complement that, because the Hadoop data platform is very good for historical insights, for data at rest. But as you know, with the explosion of the Internet of Things and connected cars and autonomous driving, it's probably more important that we're able to better manage the data in motion between the sensor at the edge of the network. And in automotive, we talk about a jagged edge of the network, because we're talking about cars that are driving around. They have intermittent connectivity. Sometimes they drive behind a mountain and you lose the connectivity. They have multiple modes of communication. It could be cellular LTE, it could be Wi-Fi, it could be DSRC, it could be various forms of communication. And how do you manage all of that in a secure way from the edge of the network and back? So this is what our data flow solution is geared to do. And at the intersection of data at rest and data in motion, we provide next generation data applications right at that intersection. And a few of those are actually on demonstration in our booth. But really, if you focus on the connectivity with connected cars, the ability to get the data from the car into the cloud, the ability to run predictive models on top of that data, the ability to accelerate data science to get the insights out of that, and it can also be used in manufacturing and warranty, even cybersecurity. So how is that relevant, now that you have a good understanding of what Hadoop is and the two solutions we provide, how is this relevant for the automotive industry? So we are working with most of the automotive OEMs and tier ones in their innovation programs, from connected cars and autonomous driving all the way through to connected manufacturing, predictive maintenance, even usage-based insurance. Because when you think about it, a lot of these innovations are really enabled through big data insights. So an example is one of the large automakers in Europe. Their CEO was really concerned that they didn't want to get behind on big data, so gave the CIO a mandate to select an enterprise data platform for the organization so that they could have a shared service, a single view of data for all of their business people to get access to the data that they need, despite the fact that they have all of these underlying systems that tend to be disconnected and tend to trap data insights, and data gets archived. So how do you make sure that no data gets left behind? It all gets surfaced into the single complementary layer in a cost-effective, scalable way. And they selected our solution in 2014. They started with 9 use cases. Today they have more than 100 use cases, and they have a very nice graphic of the life cycle of the vehicle, and they have these use cases kind of stack ranked against each stage, and it's pretty well distributed. So data is exploding within automotive right now, and the use cases that we're seeing are being evenly applied pretty much across the vehicle life cycle, from sales and marketing, through engineering, through supply chain, manufacturing, all the way through even in finance. But I'm going to focus more on what we are doing at this event. But just to give you a flavor for the key takeaway that we'd like you to get is with the connected car, you have a tremendous amount of data that's coming off that car now. So you have data on the performance of the vehicle, how the driver is experiencing that vehicle. And the question is, how can you really correlate that with external sources like traffic, weather, infrastructure? And also, how can you compare how the car was designed with how it was actually engineered, and how is it actually performing versus how it was designed? How can you close that performance feedback loop with the vehicle? So the challenge that most automakers have is the fact that their systems have evolved over the years, in many cases through different acquisitions. So they got, how many different design systems are there involved in the vehicle design process? It could be 10 or 15, 20. How many different manufacturing systems? How many quality? So all of these systems tend to be disconnected. And to be able to close that feedback loop and to do what companies like Tesla are doing, where they are monitoring exactly what's going on. They have their drivers opted in to share their data. They are updating and refreshing that HMI experience, maybe even on a monthly basis. And their customers who, many of my friends in the Bay Area have Teslas, they absolutely love them. So how do we close that loop faster? So there are 2 ways of closing that loop. You can either spend hundreds of millions of dollars and years to try and integrate all of these underlying systems to get them to better communicate, or you could close that loop in the data. So the takeaway that I'd like to leave you with is you can actually close that loop in the data in a rapid and a cost-effective way, where you can surface data from these underlying systems that have developed in silos. You can surface them into a single view, and you can put that in the hands of the business as a shared service, enable the business to use the tools that they want to look for patterns and surface. If they want to use Tableau and ClickView, or if they want to use SAS, etc., they've got their choice on how they want to operate on the platform. So one of the demonstrations that we have is where our data flow solution is communicating with the next generation telematics control unit that was announced yesterday by Qualcomm. Matt Eichenberger did a very elegant job of describing how this unit really converges all of the communication technologies within the vehicle into a single unit. So LTE, Wi-Fi, Bluetooth, DSRC, etc., all in one unit. And we're working with Qualcomm just to demonstrate how the data flow solution has an intelligent agent that runs. It's a C++ with a solution with a very small footprint that runs on that device embedded in the vehicle, and enables on the vehicle, it intercepts all of the data coming off the networks of the vehicle and looks at the message types and the data to determine, is this data that needs to be sent in real time over cellular LTE right now, or can we wait and maybe transfer that data at a lower cost where we get to a higher bandwidth Wi-Fi hotspot. So the demonstration that we have in our booth and also in the Qualcomm booth is of a vehicle on a trip, and as it's traveling along, it's monitoring where it is in relation to the next Wi-Fi hotspot. It's also looking at things like the geolocation, which it's sending up in real time via LTE. And as soon as it gets in range of that Wi-Fi hotspot, it will then it'll activate the Wi-Fi modem and send that data to the cloud in that mode. So this is very good for, as I've mentioned, the data flow solution provides some unique capabilities that are not available in a lot of these data communication protocols. Things like the ability, if it's an intermittent connection, the ability to reestablish connectivity, to prioritize at that point which data should go first versus other data that can come later. It has full data provenance and audit trail. It was actually developed based on 8 years of engineering at the NSA, and they encountered just about every kind of data flow use case and scenario that you can imagine, and they got to a point when they wanted the community to continue to innovate it, so they open sourced the solution, and the engineers that created it created a company that we acquired. And because our DNA and their DNA is exactly the same, where we open source the solution, we have the community, we work together on that together, co-innovate on that, and that's really evidence of what we could do very quickly together with Qualcomm. We're also working with, we were very fortunate and honored to be invited by Matt Jones and the RVI, or Remote Vehicle Interaction Team for Geneva, to work to contribute what we can to the data platform for communication between the vehicle and devices, the vehicle and the cloud, the vehicle and other vehicles and infrastructure. Since we are 100% open source with the proliferation of open source Linux in the vehicle, I think it's a beautiful marriage, and very, very happy to be working on that. So as I'd mentioned, just a few more points. The business can, once the beauty of the data platforms is it allows you to bring all that data together into one single view. And on top of that, we have relationships with the companies that provide the data visualization tools that your business users love to use. Tableau, ClickView, SAS. We've got Data RPM in our booth that are doing incredible things around data science. So if you think of, once you have all of this data in one place, how are you going to make sense of it? How are you going to find the needle in the haystack signal that could indicate a problem amongst all of these, incredible amounts of data? And that's where data science and machine learning really come into play. But this is a very manual-intensive, labor-intensive process where it's really error-prone, because the general way of doing data science is you get a sample data set that you extract out of your data, and then you put that into, let's say, your PC or your laptop, and you start running these different machine learning algorithms to figure out which ones are going to give you the best accuracy in terms of predictions and less false positives. And then you take that and you put that in, you take that machine learning algorithm and you try and run that on the real world data, the full data set, and you find that that data set was not representative of everything that's happening. So it's not relevant, it's obsolete. So by the time you've spent maybe a couple of months to figure that out, everything's changed. So you start from scratch. So the easy button is in our booth, and this is what our partner Data RPM are doing. So they call this meta machine learning. This is almost like machine learning 2.0. It's where you have a repository of machine learning algorithms, and they really focus on automotive and industrial. So they've got industry-relevant algorithms in this repository, and they also have a way of profiling the data automatically. So it looks at the characteristics of the data and compares that to the different algorithms that are available that in the past have been really good at running against that data from a predictive perspective. And then it tests them out in parallel. So there could be 5 or 6 that they think these are, out of the 10,000 algorithms, these are the 5 or 6 that are really going to be close to what we're looking for. It can test those out and give you a sense of which one is the best. And then it also can generate the actual Scala code if a data scientist actually wants to get under the covers and fine-tune that even further. And even better, instead of taking that sample data set out and working on a sample data set to fine-tune the model, it runs at scale on the full data set on the Hadoop data platform using the Spark in-memory engine. So this is really a game changer. So if you think of the labor savings that this will have, in terms of getting to your algorithm 30 times faster, et cetera. So this really is a game changer, and these are some of the dashboards. As you can see, we have a predictive maintenance use case, which is live at our demo, which you can see. We're right next to Qualcomm outside. And this kind of gives you some of the graphics of what the solution is doing behind the scenes for you, rather than you having to do that yourself manually. I think I'm out of time. We also have some other use cases with Progressive Insurance, one of our customers who are really transforming how usage-based insurance is being done. They have 10 billion or 10 to 15 billion miles of data. We're talking GPS per second for every trip. And they're able to correlate that with road conditions and traffic and weather to reassess the risk profile of drivers. And this has resulted in a dramatic increase in terms of revenue for them by having risk profiles that are more accurately applied to actual drivers and real data. So in the past, they only had about 25% of their data. It took them about 20 to 30 days to run these UBI models on a very high-performance compute environment. They moved that onto the Hortonworks data platform, and they literally are running these UBI models with 100% of the data in hours. I'll just conclude here. Again, the big takeaway that I'd like you to take away here is that you don't have to spend a lot of money to reintegrate all of your underlying systems to make use of the data that's collecting off the cars. You can actually bring that together in a single view, a single complementary data layer. This is non-disruptive. It complements what you have. 2 to 3 orders of magnitude lower cost than traditional means. You don't have to boil the ocean and get all of the data for the whole life cycle of the vehicle in day one. You can decide, if you want to start with just connected car data today, and maybe you want to have a look at quality, maybe warranty, it could be the paint shop, wherever you'd like to start, we'd be happy to work with you on that. And that's all enabled through the ability to have your data at rest with data in motion, and at the intersection of that, these next generation data applications that we have at our booth. So at that point, I'll conclude and be happy to take any questions.
Thank you very much, Grant. So we haven't had any questions on Slido, but does anybody in the audience want to? Hello. Does anyone want to ask any questions while we've got Grant on stage?
My apologies for keeping you from lunch, but if you'd like to join us at our booth, we'll be out there all afternoon, and we'd love to talk with you about how we can help you. Thank you.
Thank you.